Okay, here we go. All right, so okay, once again, I'm going to strongly recommend you kind of participate in this, but I'm not going to. If you'd rather work on stuff, if you want to go to the back and do that, I'll give you that opportunity. Let's just go through, and we can skip through a bunch of this. I'm going to suggest maybe the properties of exponents we don't need to spend a lot of time on. Is that right? I'm guessing based on what I've heard that seems right. Stop me if I'm wrong. If there's one you want to go through, tell me. But I'm sort of thinking maybe like this guy we could avoid. So what if we go down to graphs of polynomials? Okay, I want to review this in a couple ways. I want to look at some things that we can do to sketch this quickly, and then we can always rely on the graph, right? So how about if we look at an example? Let's do one where we actually make a table. And then we'll talk about maybe some ways that if you really get good at this, which I think we can start to get there a little bit, you could maybe even avoid having to do the table for stuff like this. Okay, so what should we do here real quick with making our table? What do we need? What are the x-intercepts? -4, +6, and 0. Okay, so we'll put those in order. So we've got -4, 0, +6. Those are zeros. Okay, let's look at end behavior. So what's going to be the result if we evaluate this thing at positive infinity? So we're going to get, what are all of the factors up here? We're going to look at the signs of all of the factors. How many factors are there, including the constant factor? 1, 2, 3, 4. Everybody agree? So we've got a constant negative factor, and then we've got the variable factors, right? So if x is approaching positive infinity, would you agree that all three of these that have x's in them are going to be positive? Okay. What could you tell me about this x squared one? What's the sign of that one going to be? Always, right? Because it's squared. Okay, so those two are always negative and positive, but then in this case, both of those would be positive. So what's the overall sign? Negative. Okay, so we know our end behavior on the right as we approach positive infinity, as x approaches positive infinity, y approaches negative infinity, so we got down behavior on the right. Okay, how about the left? First one's negative, second one's positive, right? Because that's being squared. Again, that's easy to miss. What about the other two? Negative. They'd be negative. Okay, and so we end up with 3 negatives, so we also get a negative infinity. Everybody agree?
Why is the -6 positive?
It's the whole factor. When x approaches a really large positive number, a really large positive number -6 is still really big and positive.
So we always think of it as a large positive number?
Well, I mean, in this case, yeah, positive infinity. You can't really evaluate a function at positive infinity, but what are we sort of saying? We're saying if we put in a huge positive number, what's the sign of that factor going to be? Right. Does that make sense? Okay. If we put in a huge negative number, this is going to be negative and that's going to be negative, but the other two were fixed. This one's being squared, so no matter what, it's positive. Any number squared is positive, right? So on the left side, when we approach negative infinity, so does the function. So it goes, when x approaches negative infinity, so does y, so it's also going down, right? Then all we have to do is just check the signs of the test points in between, right? So a point in between -4 and 0, let's just pick -2. If I plug in -2, what are we gonna get? Well, we get a negative constant factor. X squared is always positive, right? What about these other two? -2 minus 6 is negative. -2 plus 4 is, so the overall sign is positive. What about between 0 and 6? So let's pick 3. First one's negative, second one's positive, right? Always. What about 3 minus 6? What's that? 3 plus 4. So once again, we get positive, okay? So that tells us everything we need. Right now we can do our sketch. So out here at 1, 2, 3, 4, 5, 6, we have a 0. At 0, we have a 0. -4, we have a 0. We have,
Because the, SY versus infinity is infinity like
say it again.
the last negative infinity, where did we get that?
Where do we get that? Because we tested up here. If we plug in a huge positive number, what are the, we know we're gonna, whenever we plug in infinity into a polynomial, we always know we're gonna get an infinite answer, but we just gotta know, is it up infinity or down infinity,
Why don't
positive or
we put
negative?
Did we put both the negative things on the left side, so it's -4?
These ones right here?
Yeah, on the chart.
Oh, right
Did we
here?
put both the negative things because there's -4? Like, why we put them on that side?
Oh, because this is like a number line. This is like the x-axis, so these have to go in order, right?
So, because there's -4.
Right,
Okay.
right. Well, I mean, even if there wasn't a -4, clear off to the left is always gonna be the limit as x goes to negative infinity. Think of the number line. That's negative infinity out infinitely far and positive infinity, right?
So the last negative infinity only ever corresponds with the first x infinity?
I'm not following.
Like, you like, I don't know.
Let me explain it a different way. So when we wanna know what the end behavior is, all we're really doing is we're just looking at this like, if I plugged in a huge positive number, what would that do to the signs of all the factors, which is gonna control the overall sign? If I plug in, think of positive infinity as being positive a trillion. If I put in positive a trillion, well, that's negative, right? Because it's just -1. That's being squared, so that's always positive. Negative a trillion minus 6 is, huge positive. Negative a trillion plus 4 is still huge and positive. If I plug, or did I say negative a trillion? I meant positive a trillion. I'm trying to go too fast. If I'm plugging in positive a trillion up here, all three of those are gonna be positive and that one's negative. What if I plug in negative, huge number, trillion, let's say? -1 is negative. Negative a trillion squared is positive. Any number squared is positive. Negative a trillion minus 6 is negative, right?
Yeah, I get that, but
So what part are you asking? I'm not sure I understand.
the last negative infinity,
What about
I
it?
still don't know why it's there, like.
Well, because look, this is the x value I'm plugging in. So let me circle some things. So this guy right here, that's the x value that I'm plugging in, right? So that's it right there. As x approaches positive infinity, this is the x row, right? What's the corresponding y value? Well, it's negative infinity. Whoops. Negative infinity. So that's right there,
Oh, okay.
right? These are just like ordered pairs. Yes.
How do we figure out where it's coming from? Like, how do we figure out if it's coming from negative up?
Because of the end behavior. So now, based on this table, right, we know that the function has to go, it's gonna have to have negative end behavior on the right and negative end behavior on the left, right? So then when it gets to this x-intercept, it's gotta be coming from below, doesn't it? Right, see what I'm saying? It's positive in between, so we got a point up here, and it's positive in between there. So how are we gonna connect the end behavior to that point? Well, pretty simple, it's just gonna go, right? Now what? Okay, now I gotta think ahead a little bit. Is it gonna cut through the x-axis to get to that point? No, it's gonna bounce, isn't it? Right? So it's gonna bounce off the x-axis up to here, and now what's it gonna do? It's gotta end down, so it's just gonna go like that, right? You see how that works? Okay, that's with the table, right? Now let's look at this real quick and say, okay, how could we maybe have even skipped the table? Because we could have. If you're really careful, you could actually skip the table. And at the very least, even if you don't do it one way or the other, it's nice to be able to say, okay, does this make sense if I look at this another way? All right, so if I were to, tell me what's the degree of this polynomial? If I did expand it all out, what's the degree going to be? X to the fourth, everybody agree? Because I'm going to have an x squared times an x to the 1 times an x to the 1. So this is a fourth degree polynomial, right? Okay, the degree equals 4. So does that make it odd or even? Makes it even. Now think about the end behavior of a generic even function. A regular even function, what's the end behavior going to be? It's going to be mirrored. Is it going to go up or down? It's going to go up, just like x squared, right? That's normal end behavior. What would be reflected or flipped end behavior would be like this, right? So how do I reflect a function? I multiply it by -1. So what is the coefficient of this whole thing? Is it positive or negative? It's negative. So what's that tell you? It's down, right? It's even, but because we have this negative out front, it's even flipped, right? So there we go. We got the end behavior, right? We can just go right to a sketch here. So we know end behavior is down. Where are the x-intercepts? -4, 0, right? And 6. Okay, what can you tell me about those x-intercepts?
The x being squared means it's tangent.
Okay, good. Right. That makes sense? So any x-intercept that's linear, that's taken to the first power, remember, those are the kind that cut right through the x-axis. So we know we're cutting through the x-axis at -6 or -4, sorry, and +6, right? But at 0, we know it's going to bounce, right? Because it's being squared, it's going to bounce, and it's going to look like a parabola, right? And so that's all I need, isn't it? I should be able to draw this thing just from that information. I'm going down on this end, so I'm going to cut up through this thing. I'm going to bounce, and I'm going to cut, and I got it, right? Okay, so you really can, if you're careful, you can do these without even doing a table. But either way, it's nice to know that you can check it this way, right? Okay, that's probably enough of that. They're all pretty much the same from there. Let's look at, yeah. Okay, except these. What about this one? It says write a quartic function in intercept form with integer x-intercepts, and we're assuming that the a is either going to be 1 or -1. So how could we take the graph and write a function? What are the x-intercepts going to be? This is really easy, much easier than the other thing we just did. Okay, so the x-intercepts are -5, -1, and 6. Turn those into factors. What's the factor that goes with x plus 5? Okay, so we end up with x plus 5 times x plus 1 times x minus 6, and because it's bouncing, it's squared. Good. Okay, this is an even polynomial based on the end behavior, right? Because the end behavior is not opposite. I didn't ask you this real quick. What would a normal odd end behavior look like? It's going to be like that, right? It's going to be up on the right, down on the left, reflected. So if I multiply by -1, it's going like that, right? Okay. So this one is flipped even behavior. So what else do I have to include? That's it. Okay. We accounted for our x-intercepts. This is a bouncing x-intercept, and it's flipped. Right? Okay? Make sense? Okay, that's the first test.
So,
Kind of. I think I'm going to skip up and do this one. I feel like this is where we need the most help is with factoring. And that makes sense. I mean, factoring's, it's kind of hard sometimes. So let's talk about these. Completely, so we're supposed to completely factor the polynomial. So what are we always, if we're trying to completely factor, what are we always going to do first?
you can take it out.
Yeah, take out a greatest common factor. That's really important. That's easy to forget to do, but you can't do that. You got to see what's the biggest thing I can factor out of all terms. What is it?
2x squared.
2x squared. Okay, so we can pull a 2x squared out front of everything, and then I'm going to put the rest in brackets, and I would recommend you do that. When I put stuff in brackets, to me it means there's still a lot of stuff going on there, right? What's left if I factor out a 2x squared? X cubed minus plus minus 2. Everybody agree? Questions on that? How did I get those? I'm just dividing each term by 2x squared to see what's left over, right? For example, just so this is in our notes, actually, I want this to be in our notes. That's what gave me that, right? Okay, so now what? Okay, factor by grouping. Good, I've got it. And how do we know that? Because it's a 4-term polynomial, right? That's the strategy that goes with a 4-term polynomial is grouping. So we'll group, and we end up with what then from the first group? What's the greatest common factor from the first group? Okay, leaving us behind with, okay, x minus 2. Plus, now what's going on in the other group? Where could I start? X minus 2. If it's going to work, we know the leftover needs to be x minus 2. And what would be 1? 1, that's the only thing I can factor out is a 1, right? But it is a 1, right? It's not a 0, it's a 1. And so then out front we've got our 2x squared, and now we're pretty much done, almost. We've grouped the two terms, we have to regroup, right? Factoring out the greatest common factor, which is x minus 2. So we get 2x squared. I'm going to undistribute or factor out an x minus 2, and what's left behind?
X squared plus 1.
X squared plus 1, right?
Yeah.
Okay, here's the other thing I see people doing sometimes. They get to a place and they're not sure when to stop. When do you stop factoring? If the instructions are to completely factor, when do you stop factoring?
When it starts becoming square.
Okay, okay, I heard several responses. I'm going to summarize all of them. When you can't factor anymore, right? So can we, is that exactly what you said? All right. So can I factor anymore? These two are obviously done, right? Because that one's linear and this is just a monomial. Can I go further with this one? No, because it's a sum of squares. And the sum of squares pattern is a dead end, right? That isn't a factoring pattern. That's the non-pattern. Okay? Questions? So that's it. How would I check this?
You just multiply it back out.
Yeah, multiply it out, right? Expand it all out and see if I get where I started from, right? I want you guys to start doing that, which is why I'm going to limit the number of retakes, so it forces you to start thinking
So
that
like
way.
how many retakes?
So I'm going to give you a total of 3 takes. So 2 retakes.
There were 6. Well, no, I had to get more.
Okay, what about this? Now this is different. This is saying find all real solutions. Okay? So what am I going to do with this guy? Okay, what do I I do with this? If I'm solving it, what am I gonna do?
2 9 10.
Those are huge numbers, but what's one way I could pare those down? And I'm not factoring, right? I mean, I might factor in the process, but my answer is not gonna be a bunch of factors. It's gonna be solutions, just values of x. Now, when I'm factoring, I wanna go back real quick. When I'm I didn't have that one up there. When I'm factoring, I have to factor out the greatest common factor and leave it there, right? I can't just divide both sides by a constant, because when I'm done, I have to be able to multiply it out and get the same answer I started with, right? So for example, if I gave you a question that said, factor this completely, that's pretty easy to factor, right? It's just gonna be 3x times x minus 2. I have to have the 3 there, agreed? Because in order to get what I started with, the 3 is an important player. But if I'm solving, what if I said solve 3x squared equals 6x? I could divide both sides by 3, right? Because now I'm not factoring just for practice anymore. Now I just want to get the values. Dividing both sides by 3 doesn't change anything, right? It doesn't change my answers. So I'm going to get x squared equals 2x. I could then make it x squared minus 2x equals 0. And now I could factor out an x and get that, right? What would the solutions be? Yeah, go ahead, grab it. That's fine. But what would the solutions be?
0.
0 and 2, right? That's all I wanted were the solutions. So it was okay to divide by 3 to get those, right? Different question when you're solving for something. It's not as restrictive. When you're solving, you just want the answer, right? Factoring, in a way, is a little bit harder because you have to leave everything there. You can't divide both sides by a number. Okay, so then back to this question. What can I do to make this easier?
Divide by negative 3x.
Okay, I could divide by negative, what would you suggest?
Negative 3x.
Negative, can't divide by x. Because if I divide by x, now there's a difference. I'm gonna go back to that last example. Shouldn't have erased it. If I can undo that. There we go. If I go back to this example right here, I started with 3x squared equals 6x. If I divided by 3x, that is gonna change things. Then I end up with x equals 2, but I lost a solution. I lost the solution x equals 0, right? So, and it's been a while that we talked about that, but it's been a long time ago. You can never divide both sides of an equation by a variable, but you're always free to divide both sides of an equation by a constant, by a number. That's fine, just not a variable. Okay, so Elton, amend that suggestion. What are you going to suggest now? I could take out a negative 3x to make things smaller. Why not divide? I like the divide by negative 3 part. That helps. Divide both sides by negative 3. And what's that going to give me? 1,000 x to the 4th plus, what are we going to get? 7. Okay, plus 729. Okay, x.
Minus 729.
Minus 729. Thank you. Minus 729. Okay, so that's as far as there's no other number that goes into both of those, right? At least that we can see. So now I've got to maybe factor this a little bit. That helped a little bit though. What can I factor out? I can take out an x. What's that leave me with?
1000x cubed.
Okay. Yeah, and good. And so now what do we see here? Okay, we see that this can be factored further as a difference of cubes. We'll have a different approach to this later when we're able to just set this equal to 0 and isolate x, but we're not quite there. That's like a chapter away. So for now, we could go a little bit further with this. This is going to break up into what? What is 1000x cubed written as a cube? 10x quantity cubed, right? So we have 10x cubed minus 9 cubed. Right? So we can factor that then as a difference of cubes, right? So we end up with x times what?
10x
right? Difference of cubes, that's A and that's B, right? So difference of cubes is just gonna be A minus B times, what?
100x squared.
Good, it's gonna be 10x squared, which is 100 times x squared,
Plus
plus
AB.
AB,
Yes.
which is 90x, that's just 10x times 9
Plus
plus
B squared.
9 squared, which is 81.
We can't do that.
Right. And you can't factor that further. Also, you know that this is guaranteed to not give you real solutions. It's an irreducible quadratic, right? So you know from that pattern, whenever we do those sum or difference of cubes, the quadratic one is not going to yield real solutions and it won't factor. What if you forgot that? How could you check? Look at the discriminant. B squared minus 4AC. 90 squared is what, 8100 minus 4 times 100 times 81. That's a lot bigger than that, right? The discriminant's going to be negative. Even if you didn't see that right away and just powered through the quadratic formula, you're going to get negative numbers under the radical, and so you're not going to get real solutions, right? But you already know that because it was the difference of cubes. So that one's done. That one's giving you 0. That one's giving you x equals what? If I set that equal to 0 and solve, add 9 and then divide by 10, right?
9, 10.
So those are my solutions. Okay? Right? Make sense? So in this case, you're only factoring as much as you need to, right? Okay? Okay, what about that? Okay, it looks terrible, but really I just have to collect like terms. And what were the instructions on this one? We were supposed to find real solutions, okay? So we're just solving it. What are we gonna do? Okay, push everything to one side. So if I subtract x to the 5th, I get 135 x to the 5th plus 108 x to the 4th. The x cubes cancel, looks like, right? 5x squared, and then minus x, minus, so that's going to be plus 4x. Did I do that right? I think so.
We get a free take tomorrow, right?
I'd give you free take tomorrow. Yeah. Okay, yes. Yeah. So now what? How many terms? Okay, and I can't factor out a greatest, oh, actually I could. What's my greatest common factor? X. So I could take out a greatest common factor. So I got one taken care of. But I'm stuck with a 4-term polynomial, so what's my strategy? Got to group, right? Got to group that. So if I group that then, inside the brackets we're working now, what's the greatest common factor of the first group? What's that going to be? Yikes. 18? No.
27.
27, there you go, 27. Okay, so we're going to take out a 27 x cubed, right?
Yes.
And what are we left with? If we take out a 27 x cubed, this is going to be, that's going to be a 5x, right? 27 times 5 is 135. And you can, I mean, obviously you'd have a calculator. You can look for common factors. We could even take it piece by piece, right? To get that 27, we could see that, okay, we could factor out a 3, and then we could keep going and get another 3, and it turns out we could get 3 3s, right? What's left here? 27 goes into that 4 times. How about over here? So we know we're going to get 5x plus 4. What would I take out to get that? 1, right? Okay, and then I've got my X out front. So now we'll regroup. We've got our X out front. I've got two terms inside the brackets. Everybody see the structure of that inside the brackets? Got a big term on the left, a big term on the right. The common factor in each term is a 5x plus 4. So we'll take out the 5x plus 4, and what are we left with?
27x cubed plus 1.
Right? Okay, and we're just solving this, so it's all equal to 0. And so now what would I do? Oh, I can go a little further with that one, can't I? What's that? Two. Good, so it's two terms, so we gotta look for a pattern, right? A factoring pattern. That would have to be a sum of cubes. 27 is what quantity cubed? 3x. So that's what I've got. That's my A and that's my B, right? So what's the purple guy gonna factor into then? Sum of cubes would be A cubed plus B cubed is A plus B, right? Times, what's A squared gonna be? You remember these patterns, right? I think I need to make you guys remember these patterns, memorize these patterns. Everybody know the patterns?
Yeah.
You gotta know the patterns. Let's look at the cubes real quick. A cubed plus B cubed breaks into the cube pattern. Sum and difference of cubes always break into a small and a big pattern. The small pattern is your A and your B. The big pattern is gonna have an A squared, an A times B, and a B squared. What are the signs gonna be? Plus, minus, plus. How do we know that? Because whatever the sign of the pattern is, always goes in the small factor. The next one is its opposite, and the last one's always positive, right? So what if I made this a negative? What if I made that a negative instead? That would change the first one to a negative and the second one to a positive, right? Okay, good?
Last one is always positive.
Last one's always positive.
My Chromebook done stuff.
Uh-oh. So then what are we gonna get here? I've got A cubed plus B cubed, right? A cubed plus B cubed. So I'm gonna get A plus B times A squared. Well, that's the quantity 3x squared. What is that? 9x squared minus AB plus B squared, right? So that's what the purple one factors into. The red one factors into, oh, it's already done, sorry, plus 4. And the blue one's already done. So if that's all equal to 0, then what are my zeros gonna be? Okay, so this one, does this give me any?
No.
Nope, that one's done, right? Because that's from the sum of cubes, so that one's done. No real solutions to that one. Here I get 0, negative 4/5, and negative 1/3, right? Okay? Okay, what about that? I'm supposed to factor that. What is that one? Difference of cubes, right? So I would write that. What's my A? Yeah, so that's going to be, that's like saying 3x cubed minus 2 cubed. So what's the pattern for a difference of cubes? A minus, because that's a minus, the small factor gets the minus. So A minus B times, what's A squared? That's A. What's that squared? Good. 9x squared plus AB plus B squared. Right? Okay. Okay, let's see. I think we already, well, let's take a quick look at this. This will be the last one I'll probably get through. what do we do? We're supposed to find the real solutions. So we're just solving. What do we do? Move it all to one side. Let's move it to the side where the leading coefficient's positive. So let's push everything this way this time, right? It'll work either way, but that just makes things a little easier. So we're gonna get if we push everything this way, on the right side, we're gonna get 6x to the fourth, let's see, plus 50x squared, plus, what's that gonna give us, 56? Is that right? You guys check me on that? Plus 5, that's right, okay, equals 0. Can I divide? I'm solving, right? I'm not factoring, so can I divide both sides by anything? What? 2? Okay. So I get 3x to the fourth plus 25x squared plus 28 equals 0. Okay, that's as far as I can go with that. Now what? Okay, right. So the thing we got to look at here, what's the strategy? We've got 3 terms, right? So how do we deal with 3-term polynomials? We deal with them either by, like we always did, even way back in Module 3 when we were doing quadratic stuff, quadratic trinomials. We're looking for either magic numbers or, in this case, bottoms up, right? Or, what else could we do? Quadratic formula, right? We could just plug in quadratic formula. What's my A? My A is 3, my B is 25, and my C is 28. But if I'm going to make this thing look quadratic, I've got to make it quadratic in pieces of x squared instead of x, right? So we're going to end up with 3 times x squared plus 25 times x squared plus 28 equals 0. Think of it this way. What if instead of x squared, what if I just had black dots? Oh, it's not a dot. What if I just covered the x squared up with a black dot? Pretend that was my variable. Then I would have 3 times dot squared plus 25 dot plus 28 equals 0. That looks quadratic, right? The quadratic formula would just be dot equals, right? So, but instead of a dot, it's an x squared, right? So we could just do the quadratic formula here, where we've got x squared equals negative b plus or minus square root b squared minus 4a. There you go. Right?
That's all she's learned from this year.
Yeah. Okay.
I just never realized it, so.